All right, for the second half of lesson 9.4, we're going to look a little bit more at creating data displays, but then also interpreting them, because we have to be informed about what we see, especially in this day and age where in the media, they are always putting graphs and pictures up there to try to persuade us to think one way or another. So we have to be critical and be able to look at that information and really evaluate it for what it is and not be fooled by what they're trying to make us see. Actually be informed about what is the true information there. All right. So we've got quiz scores and students' grades. What kind of display should we do? What do you think? Maybe you're thinking a bar graph, because then we could see the change in the quiz scores because it's on category, quiz 1, quiz 2, quiz 3. Maybe you're thinking a line graph, because since they ordered the quiz right, that would be over time. So quiz 1, then quiz 2, then quiz 3. Maybe you're thinking a stem and leaf plot to see the distribution of quiz scores. I would stay away from the stem and leaf just because I think that the number of the quiz does matter, where if we put that in a stem and leaf plot, that gets lost. Similarly, if we were to do a box and whiskers plot, we would be able to see the distribution of the scores, where they're scoring, how wide that's spread, but then we also lose the order of the quizzes. And I feel like since they put the order of the quizzes, that does matter. So let's do I'm just going to do a line plot just because it'll be real quick and easy for me to draw. So I've got quiz 1, quiz 2, quiz 3, 4, 5, and 6. So this is the quiz number. And then up my y-axis, I'm actually going to do a break since the lowest quiz score is a 77. So I'm going to start and I'm going to go 75, 80, 85, 90, 95, and 100. Now, your intervals should be the same for your scale. Mine's not perfect, but you get the idea. So for quiz 1, they get an 82. For quiz 2, they get a 77. Ooh, that dropped a little bit. Quiz 3, whoa, 91. Quiz 4, 88. Quiz 5, 100. And quiz 6, an 84. Now, by connecting these, it allows me to see that overall it looked like they were going up, maybe until this last one over here. But we can see the difference between the quizzes. It also allows us to see really quickly, oh, the second quiz was their lowest score, and quiz 5 was their highest. Like, I'm able to interpret it a lot quickly by putting it into a display, rather than just reading all of those numbers on a table. All right, so now we got to think about what are the appropriate displays for each of these situations. The number of students in a marching band each year. Again, that's happening over time, so maybe we would want to use a line graph for that. Or I could see your argument for wanting to have a bar graph and saying that is the category, the year that you're talking about. If we're comparing people's shoe sizes and their heights, those are two variables that we're looking at. If we want to see that there's a relationship, a scatter plot, like we just did at the beginning of the chapter, might be the best idea to see. If they're taller, does their shoe size increase? The population of the United States divided into age groups. So the United States is the whole. Dividing it into age groups are the parts. So in that case, a circle graph is probably going to be your best option. And then if you wanted to argue, I could see the argument for this. If we did an interval for our ages, we might instead want to do a histogram. So maybe you say 0 to 3-year-olds, then 4 to 7-year-olds. Then we could go on those age groups and then create a histogram with the frequency in which they occur. That would work as well. I could see that. Now the last one, the percent of students in your school who play basketball, football, soccer, or lacrosse. A circle graph might be a good idea, or maybe a bar graph where you have these categories of them and then we're looking at number of students within each. But I guess I should have read a little bit more carefully, because if we're looking at the percents of the students, we might want to do that frequency chart instead. So a lot of these is really about the point that you're trying to get across, helps you decide which route you're going to go or which display you're going to choose. Sometimes it depends on who your audience is. What do I want them to get from it? What do I want them to interpret from it? And so you have to choose the one that's most readable. Sometimes it's easy to see, oh, this applies for this data set. I know what I'm going with. But again, this is why I like this so much, because in math so often we don't get to choose. You get to choose and you get to interpret when we're looking at these data sets. All right. You record the number of hits for your school's new website for 5 months. That's over here. You've got it. Tell whether the data display is appropriate for representing the number of hits and how it changed over 5 months. So this is exactly what I was talking about earlier. What makes sense, or how are we trying to trick people into persuading a certain way? So I want you to think about A, B, or C, which one makes the most sense? All right, so if we look at the number of hits, just in our recording here, we can see that the number of hits is going up each month. Now, which one of these can we rule out right away? Hopefully we're saying B. Because does that really show what we're trying to look at? The number of hits and how it changed over 5 months? No, I don't even know how many months that is. I can see the number of hits and how often it falls in that category, but the months are totally lost. So now I'm down between A and C. Which one? Do they both show that they're increasing? Yep. What else could we do? How do we pick? This is where your interpretation comes into play. So this is what I want you to think about while you're looking at these two graphs. How does the bar graph show that it's increasing over time? How does the line graph show it's increasing over time? Hopefully you're saying the height of the bars and the dots on the line. Now I want you to think about, how are these two graphs similar? Do you notice that if we were to plot a dot at the midpoint of each of these bars and connect them, it would look like our line graph does over here? Now you have to think about, if I'm trying to show this to someone else, and I'm trying to show that the hits are increasing, what display would I choose to use? This is where it's open to your interpretation. All right, which of these two graphs is misleading? This is exactly what I'm talking about. You got to be informed. Which one is misleading? Is it the left or the right? Did you guys notice over here that it says the total revenue is in billions of dollars? Does it look like this one is really changing at all? Doesn't it look like the revenue is just maintaining kind of flatlined? But do you see how the one on the left has the break? And so we're skipping all the way up to 9. We don't even look about those numbers. If I was trying to say, hey, look at the increase in revenue over time, holy cow, I'm going to pick this left one, because it makes it look like it's really going up, hardly drops, and still going up. If I want to show that the box office revenue is pretty flat over time, it's pretty constant, stable, then I'm going to pick this one. It shows that it's stable over time. Now, you might think, and I would agree with you, that this break and then focusing on this small interval for the entire graph can be a little bit misleading. That's why you, as the consumer of all of this information, you gotta be informed. You have to think about it. It's just like in those commercials when they say 2 out of 3 dentists recommend this toothpaste. Well, what 2 dentists did they ask? Did they ask their friends? Or did they literally only ask 3 dentists? Or did they ask 300 and 200 said that they would recommend it? Because that makes a difference. You have to be informed and you have to be critical. A volunteer concludes that the number of cans of food and boxes of food donated are about the same, right? That's what they're saying. Oh, look, they're about the same. Is this conclusion accurate? No. Why not? Calculate how many cans of food there are and how many boxes. So I counted 11 cans, but each can is worth 20 cans. So 11 times 20 gives me 220 cans total. And then I had 6 boxes of food. Well, 20 per box, 6 times 20 is 120. Although the pictures make it look like they were the same. Those are drastically different numbers, 220 and 120. And that is because the pictures are such different sizes. So you have to be careful. If you choose to make a pictograph, all of your pictures in the key should be a similar size. All right, take a look at each of these graphs. What makes it look misleading? For A, did you notice how the tickets are getting wider? The tickets should not be getting wider. Also, do you notice how we got that little groove in the ticket? Is that misleading? How do you know where it stops? There's 2 tickets here, 2 here. Do I count from the top of the point of the ticket or the left side? I don't know. That's misleading. We also have a break in the graph over here, so we're skipping all the way up to 35. You have to be careful about the information that you're given. Now take a look at graph B. We're talking about billions of dollars. It doesn't look like much of a change, right? But really, that could be a pretty significant change if we go from just over $10 billion to almost $14 billion, right? But the other part of this that's misleading is that the graph, if you look, the widths of all of those bars, they get wider as you go up. That's not supposed to happen. The bars should stay the same width every single time. So you have to be careful, you have to interpret, and you have to be cautious, and you have to be critical of the information that you're seeing. All right, that's a wrap for lesson 9.4. You can do the homework, and actually, that is all of the lessons that we have for chapter 9. So we're looking at data displays, interpreting information, and how to relay that information to other people.